All right, so the way TBIL really wants to show this is by really utilizing that transformation from the standard basis vectors into our new space, right? So if you want to think about this that way, you're going, okay, I have S of this vector 1, 0, 0, the one we think of as I, right? And if I were to evaluate that, well, all of my X's would be 1, the Y's and the Z's go to 0. And so hopefully we're seeing that pattern that we can leverage later that, oh, this is just the coefficients on our X terms of that end result of this transformation. In fact, it might be helpful to rewrite this transformation as a linear combination, right? -2, 3, -6, 6, plus y times that, to really see those transformations of the standard basis vectors. So we are looking good here. If I wanted to do this, I could do it for all of them. I'm going to get lazy here, and I'm just going to write down E2 instead of rewriting that. That's going to be all of my y's, so 0, 1, 4, and -3. And the transformation to E3 would be just the z's. Boom. Cute. Now, this gives us rise to our standard matrix. There's no set way. A lot of people just use A, but our standard matrix is each of those column vectors that we just found the results, right, from this transformations written as the columns of my matrix. So -2, 3, -6, 6, 0, 1, 4, -3, and 1, 5, 2, and 4. All right. The next thing we want to do with this is use that in some way to find the transformation of a certain thing. But in this case, we really have like every way to write this, so there's no reason to do it on this problem. We'll look at that second task that TBIL has in a second video.